Today we're going to prepare nitromethane via a classic reaction starting from chloroacetic acid. First we measured out 45 grams of solid sodium hydroxide into a beaker. And now we've measured out 120 ml of cold water. We're going to add the water to the sodium hydroxide and stir to form a solution. The mixture will get hot, so caution. Once dissolved, we need to get this chilled down to fridge temperature, so we placed into a storage bottle and put in the fridge for 2 hours to cool. Okay, here we go. Here's our starting material, 100 grams of chloroacetic acid. Do know that this is not a very efficient reaction, and to make nitromethane from chloroacetic acid, which is quite hard to obtain, is not a very practical way to synthesize nitromethane on any sort of scale. Be careful with chloroacetic acid as it's toxic and can absorb through the skin. Wear gloves when handling, but you should be wearing them anyway, right? We're going to mix the chloroacetic acid with 50 ml of water. First we've got the chloroacetic acid in a large 600 ml beaker, and with a magnetic stir bar. And here's the water. We place this in a larger container on top of a magnetic stirrer. And now we've got about 120 grams of ice cubes. And we add these to the chloroacetic acid in order to chill it right down. We've also set up an ice bath in the container around the beaker using ice and cold water. It's getting pretty chilly in there. What we need to do now is use our cold sodium hydroxide solution we prepared to neutralize the chloroacetic acid. Doing this will release heat, but it's important we don't let the temperature rise too high. Here's our chilled sodium hydroxide solution. We add a small amount to the stirred chloroacetic acid. The temperature increases slightly but quickly drops again. So we add a bit more. Now we're up to about 10 degrees C and most of the ice in the beaker has dissolved. This is where we need to slow down with the addition. It's important not to allow the mixture to go above about 20 to 25 degrees. Towards the end of the addition we start to measure the pH of the mixture. This is still on the acid side, so we'll add more sodium hydroxide. Let's check again. Not strongly alkaline, but about pH 9. This is where we want to be. Here's our slightly alkaline sodium chloroacetate solution. Let's get set up for the reaction. We're going to use a liter flask. The reaction produces some bubbles, and if it gets too hot there's a risk it will foam, so we want a flask with plenty of headroom just in case. We've got a stopper in one of the outlets and a thermometer adapter and thermometer in the other. We add the sodium chloroacetate solution. Now for our other reactant. This is 74 grams of sodium nitrite. You will note that in contact with even weak acids, sodium nitrite reacts forming nitrous acid, which is very unstable and rapidly decomposes to nitrogen oxides. Chloroacetic acid will decompose the nitrite, hence the need to neutralize it before the reaction using sodium hydroxide. We're going to dissolve this in 70 ml of warm water. As the salt dissolves, it will cool down, so dissolving takes a bit of stirring. We're pretty much there. First we've got our apparatus set up with the flask on a hot plate, and set up for simple distillation without using the thermometer to measure the vapor temperature. We've got a regular receiver and flask. We're stirring the mixture slightly to begin with using a small stir bar. And we've got a thermometer measuring the liquid temperature in the flask. This is important as temperature control is critical. We removed the stopper and placed a funnel in the flask neck. And now we add the sodium nitrite solution. There's no obvious change in temperature at this point. We left the mixture stirring for a few minutes to react. What's happening now is the formation of our intermediate nitroacetate compound in the solution. Then after a few minutes we switched off the stirring and started to strongly heat the bottom of the flask. The procedure calls for a naked flame, but we're not too happy about flames and nitromethane, so we're using the hot plate. The idea is to get the solution at the bottom of the flask hot. Once the reaction kicks off, it's exothermic and should be self-sustaining, but we don't want this to get out of control. We're watching the temperature closely. First thing we notice is a slight darkening of the solution to a yellow and then to an orange color. And at around 55 degrees C we can see the first tiny bubbles forming from the bottom of the flask. This is carbon dioxide being produced as our nitroacetate decomposes. The mixture turns more orange in color, and at around 65 degrees C we can see more bubbles forming throughout the solution. Now at about 70 degrees and we've got some water condensing in the flask. And at about 80 degrees the bubbling increases rapidly to this point. We removed the hot plate at this point to see if this would be self-sustaining. The reaction increased slightly in intensity, but felt very smooth with the temperature only rising slowly. After about 10 minutes the temperature was around 90 degrees C and we started to get some distillate coming over. To begin with, this was slow, but picked up after a while. The natural temperature reached a peak of about 95 degrees C, at which point the reaction mixture looked like this. We started to get two layers forming in the receiving flask, a slightly oily cloudy bottom layer with a faint yellow color. Once the reaction appeared to die down slightly after about 40 minutes, we brought a hot plate back and applied gentle heat using an air gap. This got things back off to a start and the reaction bubbled away vigorously, but again without getting out of control. After another 15 minutes or so of gentle heating we put the flask back on the hot plate directly and heated so that the temperature was around 100 degrees C. This kept the mixture boiling. We dropped a sheet of indicator paper into the reaction mixture to have a look at the pH. A byproduct of the reaction is sodium bicarbonate, and with the heat this decomposes into sodium carbonate, which is strongly alkaline. This is supposedly the reason for the low yields encountered in this reaction, as the alkaline byproduct can decompose both the nitroacetate reactant and the nitromethane product. Interesting, the mixture appears to be neutral, or just slightly acidic. After a few hours of distillation the layers are now much more apparent. We kept this slow distillation going for a total of 2.5 hours. Once we'd collected around 150 ml of distillate, we transferred this to a separate container and then continued to distill. We collected about another 40 ml of distillate, but there was no apparent oil coming off as a separate layer, so we stopped heating at this point. We did a final test of the pH of the reaction mixture as it was cooling down. strongly alkaline. Here's the distillate. About 180 ml in total with a pale yellow bottom layer. We poured this into a separating funnel. Then we added about 20 grams of sodium chloride salt in order to saturate the aqueous layer and try to drive out any dissolved nitromethane. After lots of shaking, the layers separated, but the nitromethane is around the same density as brine, so it took a while and a bit of tapping the funnel. We then separated the bottom layer as best we could. And then added some anhydrous calcium chloride granules. We removed the bottom layer of saturated water using a pipette. And then dried the liquid using some more calcium chloride. Here's our product. 22 grams of nitromethane. We could distill this for greater purity, but it seems relatively pure as it is, so we'll see how we get on with some subsequent reactions. This is a 34% yield on starting chloroacetic acid, which isn't really that bad and is about the same as the larger scale Morgson reference that we used for the reaction. Let's do a test to prove it's nitromethane, and combine this with a precautionary note. Here's some solid sodium hydroxide. Nitromethane has a special property in that it reacts extremely violently with strong alkalis. That was 3 drops. So please don't get this anywhere near solid alkali or attempt this on a larger scale. It could explode. That's it. Stay tuned to see what reactions we've got planned next.